We are the group one, and our topic is Internet of Things. Our topics are the introduction, define and describe analytics, application development, cloud networking, cloud storage, control theory, data storage, decision theory, electrical engineering, electronics technology, interoperability, logistics and inventory tracking, M2M machine-to-machine communication, modeling networking, RFID or radio frequency information device, sensor, software development, supply chain. So we're gonna talk about first the history of Internet of Things. In 1999, Internet of Things was first used by British technology pioneer Kevin Ashton to describe a system in which objects in physical world could be connected in the Internet by sensors. Internet of Things generally refers to scenarios where network connectivity and computing capability extends to objects, sensors, and everyday items not normally considered computers, allowing these devices to generate, exchange, and consume data with minimal human intervention. There are a lot of definitions of Internet of Things. In IAB, or Internet Architecture Board, one of their definitions of IoT denotes a trend where a large number of embedded devices employ communication services offered by Internet protocols. Many of these devices, often called smart objects, are not directly operated by humans, but exist as components in buildings or vehicles, or are spread out in the environment. Smart objects are devices that are typically have significant constraints such as limited power, memory, and processing resources or bandwidth. A global infrastructure for the information of society, enabling advanced services by interconnecting things based on existing and evolving interoperable information and communication technologies. According also to IEEE Communication Magazine, Internet of Things is a framework in which all the things have representation and presence in the Internet. More specifically, the Internet of Things aims at offering new applications and services bridging the physical and virtual worlds in which machine-to-machine or M2M communication represent the baseline communication that enables the interaction between things and application in the cloud. According also to Oxford Dictionaries, Internet of Things is the interconnection via the Internet of computing devices embedded in everyday objects, enabling them to send and receive data. Settings for Internet of Things. Application. Settings for IT applications are pre-human. Examples. Humans are devices attached or inside the human body. It's like our body. Examples. Devices like wearables and ingestibles to monitor and maintain human health and wellness. Disease management, increased fitness, higher productivity. Next is home, which is buildings where people live, like our buildings. Literally. Home controllers and security systems. Retail environments, spaces where consumers engage in commerce. Stores, banks, restaurants, arenas, anywhere consumers consider and buy. Self-checkout in store offers inventory optimization. Next is offices, spaces where knowledge workers work. Energy management and security in the office buildings improve productivity, including for mobile employees. Next is factories. Standardized production environments, places with repetitive work routines, including hospitals, farms, operating efficiencies, optimizing equipment use and inventory. We need also like connection for this one, like the internet access. Work sites, custom production environments like mining, oil and gas construction, operating efficiencies, predictive maintenance, health and safety. Next is vehicles, system inside moving vehicles. Vehicles including cars, track ships, aircraft, and train condition-based maintenance, usage-based design, and pre-sales analytics. Cities, urban environments, public spaces, infrastructure in urban settings, adaptive traffic control, smart meters, environmental monitoring, resource management. And outside, the outside uses includes railroad tracks, autonomous vehicles, and flight navigation real time. Analytics. Analytics is a system computational analysis of data or statistics in broad sense. It can help companies understand the Internet of Things data of their disposal with an eye towards inducing maintenance costs, avoiding equipment failures, and improving business operations. So analytics, you're analyzing, that will be some problems, like that one. Application development. Building an application for Internet of Things, Internet of Things application or things themselves. What's the best way to build an Internet of Things application that can do anything from control home appliances remotely to inform an aero engine manufacturer that one of its engines somewhere in the world needs servicing to gather meteorological data from sensors to provide weather forecasts? So for application development, so this is actually developing an application by the use of the Internet of Things, like those smart apps. Cloud networking and computing acts as a sort of front end and Internet of Things is an increasingly popular services that offers several advantages to Internet of Things, and it's based on the concept of allowing users to perform normal computing tasks using services delivered entirely over the Internet. As a paradigm for big data storage and analytics, the combination of cloud computing and Internet of Things will enable new monitoring services and powerful processing of sensory data streams. Characteristic of a cloud networking or computing. It is a web-based service that can be accessed without any special assistance or permission from other people. However, you need at minimum some sort of internet access. 2. It involves broad network access, meaning it offers several connectivity options. And 3. Allows for resource pooling, meaning information can be shared with those who know where and how to access the resource anytime and anywhere. And 4.1 is features rapid elasticity, meaning users can rapidly scale the service to their needs. You can easily and quickly edit your software setup, add or move user, increase storage space. And 5 is measured service, meaning you get what you paid for. This is how cloud computing works.
Hey everyone, good day. I'm Saldy Barriga and I'm here to report on cloud storage, control theory, and data storage. So, cloud storage. Cloud storage is a model of data storage in which the digital data is stored in logical pools. The physical storage span multiple servers and often locations. And the physical environment is typically owned and managed by hosting company. These cloud storage providers are responsible for keeping the data available and accessible, and the physical environment protected and running. So here's the types of cloud storage: the personal cloud storage, public cloud storage, private cloud storage, and hybrid cloud storage. So the personal cloud storage, also known as mobile cloud storage. Personal cloud storage is a subset of public cloud storage that applies to storing an individual's data in the cloud and providing the individual with access to the data from anywhere. It also provides data syncing, and sharing capabilities across multiple devices. Apple's iCloud is an example of a personal cloud storage. So, public cloud storage, it is where the devices and storage service provider are separate and there aren't any cloud resources stored in the enterprise's data center. The cloud storage provider fully manages the enterprise's public cloud storage. So, the private cloud storage. In private cloud storage, the storage provider has infrastructure in the enterprise's data center that is typically managed by the storage provider. Private cloud storage helps resolve the potential for security and performance concerns while still offering the advantages of cloud storage. And last but not least, the hybrid cloud storage is a combination of the public and private cloud storage where some critical data resides in an enterprise's private cloud while other data is stored and accessible from a public cloud storage provider. Here are some advantages and disadvantages. There are there are many to use cloud storage. Most notable is file accessibility. Files stored in the cloud can be accessed at any time from any place so long as you have internet access. Another benefit is that cloud storage provides organization with off-site backups of data which reduces costs associated with disaster recovery. Unfortunately, the biggest disadvantage to cloud storage is that users are limited by bandwidth. If your internet connection, if your internet and connection is slowly or unstoppable, you might have problems accessing or sharing your files. Organizations that require a large amount of storage may also find costs increase significantly after the first few gigabytes of data stored. So here we are. We have a second report for me is control theory. Control theory is an interdisciplinary branch of engineering and computational mathematics that deals with the behavior of the numerical system with inputs and how their behavior is modified by feedback. So here are the branches of control theory: the linear control theory, the nonlinear control theory. Okay. So the linear control theory, this applies to system made of devices which obey the superposition principle, which means roughly that the output is proportional to the input. They are governed by linear differential equations. So nonlinear control theory, this covers a wider class of a system that do not obey the superposition principle and applies to more real-world systems because older control systems are nonlinear. And the third one for my report is data storage. So the data storage is recording of information. Recording is accomplished by virtual any form of energy. So thank you everyone for listening to my report, and I hope you like it.
I'm DIanne Salvar, reporting about the decision theory or the theory of choice. Decision theory is a study of reasoning underlying an agent's choice, and it is concerned with the choice of individual agents. Decision theory is an interdisciplinary topic studied by the economists, statisticians, psychologists, biologists, political and social scientists, philosophers, and computer scientists. Decision theory has two branches, which is the normative decision theory and descriptive decision theory. So, normative decision theory gives an advice on how to make the best decisions given a set of uncertain beliefs and a set of values. Descriptive decision theory is to analyze how a system, possibly irrational agents, actually make the decisions. So decision theory has three classes. The first one is decision under uncertainty, which a manager has far too much information to choose the best alternative. The second one is decision under a conflict, which the manager has to anticipate moves and counter moves of one or more competitors. And the third one is decision under uncertainty, which a manager has to dig up a lot of data to make a sense of what is going on and what is leading to. So the next topic is electrical engineering or electrical technology. So electronic technology is a field of engineering that generally deals with the study of applications of electricity, electronics, and electromagnetism. It is subdivided into a wide range of subfields including electronics, digital computers, power engineering, telecommunication, control system, radio frequency engineering, signal processing, instrumentation, and microelectronics. Many of these subdisciplines overlap and also overlap with other engineering branches, spanning a huge number of specializations such as hardware engineering, power electronics, electromagnetics and waves, microwave engineering, nanotechnology, electrochemistry, renewable energies, mechatronics, electrical materials science, and many more. So the next topic is the logistic interoperability. Comprise the ability to provide and accept a logistic service that is fuel, spare parts, ammunition, provisions, medical services, and transport. Customarily within NATA, logistics have been a national responsibility and individual nations have maintained their own lines and support. The same has been true of the United Nations operations. During the Cold War, when NATA's mission was exclusively territorial defense of the efficiency of parallel lines of support were accepted to NATO has however made a considerable effort to achieve the standardization of certain categories of fuel and ammunition. I mean, connectivity for replenishment at sea and air-to-air refueling, and to standardize more logistic procedures. Logistic cannons generally permanently deployed into the theater and deployment distance are likely to be greater for most NATO members than during the Cold War. NATO has developed a concept of shared alliance or national responsibility for logistics. For an expeditionary operation, it is securely sensible to establish logistics base and sites under an NATO logistic commander and arrange protection.
I'm here to report that mainframe, which is machine-to-machine communication. Machine-to-machine communication is a communication is often used for remote monitoring. In product restocking, for example, a vending machine can message the distributor when a particular item is running low. It is an important aspect of warehouse management, remote control, robotics, traffic control, logistics services, supply chain management, fleet management, telemedicine. The key components of an end-to-end system: sensor, RFID, Wi-Fi or cellular communication link, autom autonomic computing software, program to help a network device interpret data and make decisions. The most well-known type of M2M communication is telemetry, which has been used since the early part of the last century to transmit operational data. Pioneers in telemetrics first used telephones, lines, and later on radio waves to transmit performance measurements gathered from monitoring instruments in remote locations. The Internet and improved standards for wireless technology have expanded the role of telemetry from pure science, engineering, and manufacturing to everyday use in products like home heating units, electric meters, and Internet-connected appliances. Products built with M2M communications capabilities are often marked to end users as being smart. Currently, M2M does not have a standardized connected device platform, and many M2M systems are built to be task or device specific. It is expected that as M2M becomes more pervasive, vendors will need to agree upon standards for device-to-device communication. Modeling network. The model networks have found widespread implementations in testing, energy, and services. Currently, in a telecommunications sphere, the concept of the Internet of Things is widely recognized as a key. In this connection, it is advisable to use an improved approach for testing devices and applications of the Internet of Things based on model networks. The article presents the structure of the model network created on the basis of the Laboratory of the Internet of Things in the State University of Telecommunication and description of features of the network for a comprehensive research of the Internet of Things. Sensors coupled with transceivers have quickly evolved from technologies purely confined to laboratory tools, bids for workable solutions used across the globe. These mobile and connected devices form the nuts and bolts required to fulfill the vision of the so-called Internet of Things. This idea has evolved as a result of proliferation of electronic gadgets fitted with sensors and often being uniquely identifiable, possible with technological solutions such as the use of radio frequency identifiers. While there is a growing need for comprehensive modeling paradigm as well as example case studies of the Internet of Things. Currently, there is no standard methodology available for modeling such real-world complex Internet of Things-based scenarios. Here, using a combination of complex network-based and agent-based modeling approach, we present a novel approach to modeling the Internet of Things, especially the proposed approach uses the cognitive agent-based computing or CAB framework to simulate complex Internet of Things network. Radio frequency information device became a useful tool in retail, logistics, healthcare, and a handful of other enterprise sectors. Is now transitioning itself into a supporting player by becoming an essential part of the next big thing, the Internet of Things. Diminished expectation. RFID tag can be viewed as a supercharged barcode with radio connectivity. RFID readers can wirelessly detect and track tag items as they move through the supply chain, are stored in inventory receipt in a sales floor or rolled down production line. RFID meets last Internet of Things where RFID is going to claim the Internet of Things is by adding the unique value of what's going on at a particular point on a specific object at an exact time. There's value in that sort of insight.
Hello, I'm Marson Rabbin Palanas, and I'm here to report about sensor and supply chain. So what is sensor? Sensor. Sensor is the device that detects and responds to some type of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any one of a great number of other environmental phenomena. The output is generally a signal that is converted to human-readable display at a sensor location or transmitted electronically over a network for reading or further processing. So there are different types of sensors. The most frequently used different types of sensors are classified based on the quantities, such as electronic current, potential of magnetic or radio sensors, humidity sensor, fluid velocity or flow sensors, pressure sensors, thermal or heat or temperature sensors, proximity sensors, optical sensors, position sensors, chemical sensor, environment sensor, magnetic switch sensor. So the different types of sensors with their applications. Typical applications of different types of sensors such as applications of speed sensor for synchronizing the speed of multiple motors. So mo ni siya ang kasagaran makita nato sa kanang mga motor kanang na speed limit niya makita yung speed. So temperature sensor application for industrial temperature control application of the PIR sensor for automatic door opening system. So ang temperature sensors mo na siya ang sensor sa temperature. So ma-measure niya ang temperature sa imuhang machine, like if ma-overheat na siya or low ra yung temperature. So sa PIR sensor, ang PIR sensor mo na siya ang sensor abot sa kananing nang musod ka sa SM kanang ilang portahan lang kanang automatic lang akuan. Kung sa motion sensor na siya. Ultrasonic sensor application for distance measurement or etc. are discussed below with their block diagrams. So software development. So software development is the process of computer programming, documenting, testing, and bug fixing involved in creating and maintaining applications and frameworks resulting in a software product. So software development is the collective processes involved in creating software programs. embodying all the stages throughout the system development lifecycle. So software development. So software development. We're gonna develop a software by making documents and testing, designing, prototyping, and about fixing what is the problem about your system. So SDLC or methodologies to support the designs of software to meet business needs. The development of software to meet the specified design and deployment of software to production. A methodology should also support maintenance, although the options may or may not be chosen depending on the project question. So SDLC methodologies support the design software to meet the business needs. So we need to consider what will be needed in making our software. And we need to determine what is the use of your software or system and needed ba siya karon. So there are types of SDLC methodologies. So there are the common types. So the waterfall model. The original SDLC method is linear and sequential, generally flowing these stages in order: identification of required software, analysis of the software requirements, detailed specification of the software requirements, software design, programming, testing, and maintenance. So identification of required software, this we are gonna determine or planning about the business needs. So analysis of the software requirements, require about what unsay imong gamiton paghimo sa imong software. So detailed specification of the software requirements, unsay gamit o unsay dapat paggamit sa imong software. Software design, by the word design mo na siya ang flow sa structure sa imong software. Ang programming dara na siya maghimo sa codes para madagan ang imong software. So testing, so before ka i-introduce nimo sa industry, dapat you need to test kung naabay siya yung mga mali or kinahanglan ba siya ayuhon or kuwangan ba siya. So maintenance, kinahanglan din na ang maintenance, importante din ang maintenance. What if na makalit lang og bug niya o diwa nimo na ibantayan, hindi masamok din ang kuwan trabaho. So waterfall and similar models are considered predictive methodologies in contrast to adaptive models such as agile software development (ASD), rapid application development, joint application development, and the fountain model. In a spiral model, build and fix, and synchronize and stabilize. Frequently, several models are combined into some sort of hybrid methodology, as is case with open source software development or OSSD. So here, supply chain. So what is supply chain? So from the meaning, supply means a network between company and its suppliers to produce, distribute a specific product, and the supply chain represents the step it takes to get the product or service to the customer. So from the word supply chain, so network yun na siya. Kung very first, kinahanglan ang producer mohatag siya og produce siya og product, gamiton niya ang product sa user ay sa mga buyer ba o user. Then ang mga user o mga buyer mo bayad sila sa producer para pag ma-maintain nato nila, mag-cycle na siya mo na ng supply chain. The supply chain management is a crucial process because an optimized supply chains result in lower cost and faster production cycle. So from the word supply management cycle, what if walay management ang imong supply chain? So what if ka na mo overproduce ka sa imong supply, then gamay ra ang buyer? So kinahanglan jud na supply chain management para makontrol nimo ang flow sa imong product or mga supply. So breaking down supply chains. So business logistics. Management refers to the production and distribution process within the company, while supply chain management includes supplier, manufacturers, and retailers that distribute the product to the end customer. So supply chains includes every business that come in contact with a particular product, including companies that assemble and deliver components, parts, and materials. So, business logistic management, sila ang mag-handle sa production o sa distribution process, while ang supply chain management, sila ang mag-handle sa suppliers, sa manufacturers and retailers sa pag-distribute sa products padto sa customer. So, the organization that make up the supply chains are linked together through physical flows and information flows. So what is physical flows? So physical flows involve the transformation, movement, and the storage of goods materials. They are the most visible piece of supply chains, but just as important of information flows. So information flows. What is information flow? So information flows allows the various supply chain partners to coordinate their long-term plans to control the day-to-day flow of goods and material up and down the supply chains. So, what is the difference between the two? So, ang physical flows, the physical information movement sa kanang pagpasapasa sa imuhang goods, materials, while ang information ang mao na siya ang mo control sa flow sa imuhang goods, if daghanon ba ang imong i-deliver karon or gamay ra ba, or dapat ba kanang dapat ba imong i-manage ba siya, kay kinahanglan jud na siya i-manage ang imong kuan kung basi ma-expire na siya or naidaot mo rin mailisan. So this is the end of our report. So we are the group 1 and our topic is IoT. Thank you.